Welcome to ePathshala lecture series on computer science. In this module of data analytics, we will be discussing about an introduction to mining. The objectives of today's module are to know about various mining techniques and to learn and understand the basics behind those mining techniques. So, the keywords related to today's module are data mining and techniques related with data mining. First, let us understand what are the differences between various analytical keywords. The first keyword that is related to analytics is, say, data science. Data science actually covers a broad area or a broad spectrum. This field actually breaks down into different areas. Say it may start from constructing a big data framework and an infrastructure for handling the data, and also configuring various softwares and hardwares that may sit on top of the infrastructure for the purpose of analysis. So, data science covers a broad spectrum. Actually speaking, this data science also deals with respect to how are we going to make use of the softwares and interfaces for handling the data, for transforming it, and finally providing a useful input as well as output for analysis for the end users. The second important term related to analytics is data analytics itself. I think we discussed the definition of data analytics in our first module. Once again, let us recollect the definition. Data analytics actually involves everything which starts from as simple as generating a simple report using an Excel to the maximum of, say, handling data science with respect to large data sets. So, this data analytics involves any techniques that deals with data for the purpose of useful transformation. And finally, we have the term data mining. Fundamentally, data mining focuses on discovery of unknown properties and use these properties for the purpose of explaining a pattern. So, this data mining deals with discovering previously unknown or hidden patterns from the given data set. Practically speaking, these three terminologies, data science, data analytics, data mining, actually go hand in hand, because we require data for the purpose of analysis and we need an infrastructure to hold the data. So, data science will deal about the infrastructure that is essential for handling the data. Analytics will talk about how are we going to analyze the data, and mining, majority of the scenario, will discuss about various techniques that will be used for explaining the unknown properties or patterns which were previously not seen from the given data. Having understood these important terminologies related with analysis, now let us start with an introduction to data mining. Data mining fundamentally is a process, that is, it cannot be a single step. So, what exactly happens in this data mining process? Initially, for performing mining, we need data. So, the first step in or towards data mining process is collection of data, in other words data collection. So, what do you mean by data collection? The data that is required for analysis will be available in many data sources or multiple data sources. And when we think about data sources, all the data sources will not have or hold the data in the same format. In other words, the data sources are going to be heterogeneous in nature, because one database may be relational in nature, another database may be functional in nature, another database may be multidimensional in nature, another database may be handling multimedia data. So, when we try to collect data from different data sources, we may end up with different types of data held in different formats. So, we are trying to collect data from heterogeneous data sources. So, that is the first step in data mining process. Once we have identified the data sources, next what is that we need to do is, we need to select the required data for our analysis. So, extracting the required data from heterogeneous data sources will be our initial step. Having identified the data that is essential for our analysis, the next thing we need to do is identify what kind of anomalies are available in the given data, because when we collect data using, say, automated data tools, there are many places where these automated data tools might malfunction, or the data that is recorded in external data sources might be wrong. Therefore, we may end up with missing information, or we may end up with inconsistent data, or we may sometimes even end up with redundant information. Therefore, we need to identify such anomalies and then eliminate those anomalies. This process of eliminating the noises or unwanted information from the given data is called as data cleaning stage. So, in the process of data cleaning, we try to identify the noises and we eliminate them by means of specific methodologies. So, the second step in data mining process is data cleaning. Having cleaned the data, next we need to concentrate towards transformation of data. The reason is the data that we collect may have anomalies. After cleaning the data is ready for analysis. But before applying the analysis over the data, we need to know whether the data that we have acquired or the data that we have collected is compatible with the analytical techniques or the analytical tools, or say the structure in which we are going to hold the data. Therefore, we need to do some kind of transformation over the data. A simple example for transformation may be, I might have collected data from say 2 different servers available in 2 geographical locations. One may be from India, another one may be from say US. Assume the data that I am trying to extract from these 2 servers are transactional data. So, the transactions that have happened in India will be in rupees, and the transaction that has happened in US server will be quantified in terms of dollars. Now, when I take these 2 data and apply analysis over it, I may be ending up with a non-compatible or completely non-compatible data set. The reason, in one data it is in dollars, in another data it is in rupees. Therefore, I need to perform a simple transformation, conversion from dollars to rupees. Or data transformation may be very simple like this. The data that I have acquired may be available in a relational table, but the tool with which I am going to do the analysis may require the data in flat file format. So, I need to convert the relational structure or the data available in the relational structure into a flat file structure. This can also be considered as a simple transformation. Many such transformations need to be applied, only then your data will be ready for analysis. So, after collecting the data, you need to clean the data, transform the data, then only it is ready for analysis. The fourth step is identifying a suitable mining technique which may be applied over the transformed data for identifying patterns. So, the fourth step is very vital for the purpose of detecting the pattern, because you need to know exactly what is your expected outcome. Accordingly, you need to choose a specific mining technique. In the forthcoming slides, we will discuss about what are the various mining techniques and how to choose a one for our analysis. As of now, we will understand that one or more than one mining technique may be applied in step 4. Once you apply mining technique, the result is going to be patterns. That is, when we are extracting a pattern, we should see to that the pattern must be previously unknown. For example, if I am trying to take a transactional data, run some analysis, and then I finally identify that if a particular person purchases say an item A, then there is a chance for the same person to purchase another item B. If suppose this information is priorly known, that is already it is known to say a sales representative or say the marketing executive, then there is no purpose behind applying our analysis. So, how good must be the pattern? The pattern must be useful for decision making. In other words, the pattern which is hidden in your data but not exhibited explicitly need to be identified. Such patterns are really useful for decision making. And in other words, the patterns must be interesting. Only then it will be useful for decision making process. So, as a result of applying mining, you need to extract previously unknown and interesting patterns. Once the patterns are extracted, the next step in data mining process is evaluating the pattern. Now, how good is the pattern, or to what extent it may be useful for decision making process? This is what you need to evaluate. So, for evaluation, there are many traditional techniques as well as metrics available for the purpose of evaluation. As a result of evaluation, we will come to know whether the patterns are really useful or not. Accordingly, relevant patterns will be taken to the next level. So, the next step or the final step in data mining process is visualization, because when you extract a pattern, the pattern need to be visualized. In other words, it need to be made understandable to the user or to the audience. So, therefore, we need to come up with visualization tools or techniques that may help the audience to visualize what exactly is the outcome. Accordingly, the experts or the audience or the users may be in a position to make appropriate decision. So, finally, we may end up with some useful patterns which may be used for decision making process. So, all these 5 steps put together only make up a data mining process. Now, having understood what are the steps involved in data mining, I told in the 4th step there are many techniques available and we need to choose one or more techniques for the purpose of making the decision. Now, we will be discussing about what are the various data mining functionalities or techniques. The first important data mining functionality or technique is concept description. Concept description can be of 2 types, characterization and discrimination. The second important data mining technique and very commonly used technique is mining frequent patterns or association rules or identifying correlations. Third one is classification and prediction, then comes cluster analysis and outlier analysis, and finally evolution or trend analysis. So, these are the common data mining functionalities. Actually, when you take a particular functionality, there may be many algorithms associated to that technique, or there may be many algorithms with which you can understand and visualize the techniques. Now, we will take each and every technique in detail with some examples and understand them in detail. First, let us start with concept description. Concept description is fundamentally how are we going to describe a data. So, as the term description indicates, it is a form of explanation. So, given a data, the data can be associated to a class or a concept. So, what are we trying to do is, we are trying to describe or provide a description of a class or a concept, and this description in general will be in the form of a summary. So, practically speaking, this concept description can be had in the form of say a summary or in the form of a comparative analysis. So, when we summarize, it is called as data characterization, and when we compare, then it is called as data discrimination. In certain scenarios, concept description may be achieved both using data characterization as well as data discrimination. What is data characterization? Data characterization is, given a data, what is it we are going to do is, we are going to identify what are the features, what are the properties associated to a given data, and then write a summary about those properties. Then it becomes a very simple summarization. For example, normally when we go to an interview, the common question that is asked to the candidate is, talk about yourself or tell something about yourself. Now, for this question, what is that we need to do is, we need to identify what are the properties that may be attractive, and we need to talk about those properties of us. So, this is nothing but a simple summarization. So, this is what is called as data characterization. So, in data characterization, we take a data and we present the characteristic features of the data with various formats or forms. So, simple examples by which we can visualize characterization are a pie chart, because when you run an analysis, the outcome of the analysis may be visualized in the form of a pie chart, which may provide you say clear cut partitioning of the actual analysis, or it may be represented in the form of a bar diagram, or it may be represented in the form of a curve, or it can even be represented in the form of a multidimensional table. The resulting description actually will be presented in a very generalized way. Sometimes it may be even be presented in the form of a rule, or also known as characteristic rules. So, what we are trying to do is, we are trying to describe a data in the form of rules. An example for data characterization. Now, in this table, we have a relation. That relation speaks about individuals residing in various locations, geographical location, say in the country Canada, their birth date, their residence, phone number, what major they have studied, whether computer science, physics or science, engineering, whatever it may be, their gender and name is provided here. Now, if this data is provided to us, then how we can summarize this is, we can actually summarize the people based on say the major that they have opted. Now, we can end up with 2 important majors. One category of major is say maybe an engineering major, another major may be say a science major. So, now I can take every individual from this database identify to which category of major this particular individual is associated to. So, I can take all the science related individuals, group them together. I can take all the engineering related individuals and group them together. Now, this generalized relation can be considered as, say, an outcome of data characterization. Further, what we can do is we can go down one more step. In this step, we may find a clear demarcation between Canadian individuals and non-Canadian individuals who are classified into either male or female category, and to what extent they actually belong to the Canadian and the non-Canadian category. So, this table will provide you a very abstract level summary about male and female ratio who are Canadian and non-Canadian in nature. So, this can be another level of summary associated to data characterization. So, with this example, we may be in a position to understand what exactly is, say, an outcome of data characterization process. Now, let us understand data discrimination. Data discrimination is fundamentally comparing two or more data. In other words, we can take a source data and we can compare it with the target data. So, what exactly we are trying to do here is, we are trying to identify some features that is in common among these two data, and we are using this feature for the purpose of analysis. Say for example, we often might have seen various advertisements in the television. Few advertisements will state clearly, say this particular product has, say, this feature, and say this feature is not available in the other product. This is a simple example for data discrimination. Or we can take two individuals from a classroom and we can compare them based on a common feature called, say, CGPA. So, what we are trying to do here is, we are trying to identify two data or more than two, make use of a common feature with which we compare them. So, this kind of analysis will result in data discrimination. So, we take a target class and a contrasting class, and then we specify the differences between these two classes by making use of common features. These two, that is data characterization and data discrimination, are two fundamental mining techniques. Apart from these two fundamental mining techniques, we have one more fundamental technique called mining frequent patterns, which is also known as identifying associations or discovering the correlations. So, in mining frequent pattern, what we are trying to do is, we are trying to identify a data that occurs often or very frequently. In other words, we are trying to make use of the probability of a particular data for the purpose of defining whether it is frequent or not. If a particular data is frequent, then we may use that data for further decision making. In real scenario, when we are trying to identify certain items or certain data that are frequent, we can also identify some other data or items that are interrelated to the previous item. In other words, we are trying to identify associations among item pairs. Let us consider an example, a customer entering, say, electronic showroom, and in that electronic showroom, assume the sales executive displays various smart televisions. The customer finally opts for one smart television. Then if the same customer looks in for, say, another product, say for example stabilizer, then, and in previous transaction, if we have traced or identified similar such items have been purchased, then we can always say smart television and stabilizer are two items that go hand in hand. Now, this is a kind of association that is exhibited among two items. Such associations and those associations that occur often or frequently is what we are trying to discover using association rule analysis or mining for frequent patterns. Now, while we are discovering such associations, what exactly we are trying to highlight here is the type of correlation or the relation that is exhibited among these two items. So, we are trying to identify such items that often occur in our transactional environment. So, this mining frequent patterns is widely used in retail domain, because in retail domain we often find few products are being purchased together. So, we need to identify such items that is being offered frequently, and such frequent patterns when identified and used for decision making will aid advertisement as well as promoting a particular product. Say for example, if I want to introduce a new product, then what is that I need to do is, I need to identify another product along with which this product may be promoted. So, I need to pair these two items together and I can offer for a discount. So, this is a simple decision making which may aid in promoting a new product which is being introduced in the market for the first time, and this is what we are trying to identify using mining frequent patterns. So, how are we going to visualize frequent patterns is by means of associations. So, when we discover the associations, how they are represented is, they are represented using multidimensional or single dimensional rules. For example, here we have a multidimensional association rule. In this association rule, we have two attributes, one is age, another one is income. Now, with respect to these two attributes, we are trying to decide whether a particular person might purchase a PC or not. So, here what does this rule states is, this rule states if a person X who is in the age range 20 to 29 and who is in the income range 20 to 29K, there is a chance that the person might purchase PC. So, the rule will have an antecedent and a consequent. The antecedent indicates a set of constraints which when satisfied will result in the consequent, which is, say for example, a decision making, which may aid in decision making. And along with this rule, you can find two metrics, support and confidence, which are used for determining the quality of this particular rule. So, support and confidence are two metrics that often accompany an association rule. There is one more example. This example contains, say, a single dimension. So, if a particular transaction T contains the item called computer, then the same person or say the same item might also contain, say, a software. So, based on appearance of computer, we also decide whether there will be a software in that or not. So, this rule is also associated to a support and confidence value. The next type of mining problem is classification and prediction. In classification, what we do is, we actually try to evolve a model that will be used for providing a category or a class label for an unknown data. Now, how do we evolve a model is, this evolution of classification model is based on, say, training. So, we will have to provide a data set. From the data set, the model has to identify suitable attributes with which it can assign a class label for a given data. Say for example, I can take a set of students and then I can identify to which particular grade the student may be assigned to based on their marks. So, from a given student database, I may have many attributes like the student name, the roll number, the department, the courses they attend, then their extracurricular activities, the subject wise mark, CGPA, etc., etc. With all these set of attributes, we need to identify which attribute may be suitable for assigning a grade. So, the model has to identify among the n attributes which of those attributes might be suitable for providing a final class label, say for example, the grade label, say S or U or say F or something like that. This is what you call as classification. Now, in classification, what exactly we do is, we actually make use of labels that are previously known. Only those labels that are previously known will be further used for the purpose of assigning a class label to any unknown data. In other words, it is actually called as supervised learning. That is, with the help of examples, we are learning. In prediction, what exactly we do is, in prediction we normally predict a number or say a numerical value. This is also similar to classification, but instead of assigning a class label, here we will be making use of, say, a numerical number. So, normally there is lot of relation between or association between classification and prediction techniques, but the final outcome is that one that clearly differentiates classification and prediction. Say one example for classification may be, we can classify countries based on their climate, and prediction may be, say, what may be the rainfall, average rainfall for a given region. This can be a numerical value, but assigning whether it is a heavy rainfall country or a low rainfall country may be assigning a class label. So, this is a simple example with which we can understand the clear distinction between classification process and the outcome of prediction process. Now, how can we represent classification? Ultimately, classification need to be represented either in the form of a if-then rule or in the form of a decision tree. So, here in this slide, you can find set of rules and say a decision tree. This rule is similar to say your association rule. Here also you have age and income, which are the two attributes with which we can decide whether say the person belongs to class A or class B or class C. So, various attribute and their corresponding values are used to decide whether a class label may be assigned to a given data or not. So, here X is going to be the data for which you are going to assign any one of these three class label. The same may be represented in the form of a decision tree. So, here in this decision tree you have nodes. The leaf nodes alone represent the class labels. All nodes except the leaf node indicate say a constraint over an attribute. So, the first constraint, which is age here represented by the root node, indicates what is the age of a particular person. If the age of a particular person is say youth, then we will have to look in for another attribute which is high. So, as per the value taken by the data, we may assign a class label. So, this is what is called as classification. The next technique is clustering. In clustering, what we do is, here we are not trying to end up with class labels which are previously known. Here we are trying to end up with new classes. In other words, we are trying to identify distribution of pattern. So, we are trying to take a data, but we do not have class labels similar to classification process, but we make use of the attribute value and distance metrics with which we can identify grouping among the data objects. And according to the groups, for each and every group we may assign a new class label. So, what principle is actually used in clustering processes? We make use of the principle called maximizing the intra-class similarity and minimizing the inter-class similarity. Intra-class similarity is the similarity within a particular group, and inter-class is the similarity among different groups. So, when we take a particular group, the similarity among the group must be very large. In other words, in a particular group, all the data members within the particular group must be highly similar, only then they can be put into one group. But if you take different groups, two different groups, the members among the groups need to be completely indifferent, only then they can be placed in two different groups. Therefore, we maximize the intra-class similarity and we look in for minimizing the inter-class similarity. So, this diagram will give you a clear picture of say a two-dimensional data plot and say the graphs or say the shapes over here indicate three different clusters. Now, you find the data points within a particular cluster are very close to each other, which indicates they are very similar. And when you compare one data from this cluster and the second cluster, you find the distance is large, which indicates say a maximum distance. So, this is nothing but inter-class similarity, and the distances within the group is called as intra-class similarity. One technique which is similar to clustering is outlier analysis. In outlier analysis, we actually try to identify or detect a data which does not comply to the general behavior of the data. And where exactly this outlier analysis will be used is, outlier analysis normally will be used for identifying fraud detections or rare event analysis. How it is detected is by making use of statistical tests or by making use of distance measures and deviation based metrics. So, we normally take data, we compare their feature, and if the feature value is greater than a threshold, then we can declare that to be an outlier or a noise. The last analysis is trend and evolution analysis. In trend and evolution analysis, what we do is we actually take a data which is associated to changes with respect to time, and then we try to model the changes. And if this change has been modeled or visualized, then it becomes a trend or simple evolution analysis. So, normally when we take stock market, we can identify how a company has performed based on its share performance in the market, stock market. So, when you map say 5 years of the company's share data, then you can find how or to what extent the share has fluctuated over a period of time, and this fluctuation can be called as a trend or say an evolution. So, in summary, we discussed about what are the differences between various data analytics terminologies like data science, analytics and data mining, and also we have understood what are the various types of fundamental data mining techniques and the working principle behind those data mining techniques. Thank you.